Hi everybody, super excited about today. We're actually starting a new chapter, some totally new stuff. We are going to be talking about right triangle trigonometry today. So next year when you take Algebra 2 Trig, you will do a really big unit on trigonometry. So we are just going to be dipping a toe, just starting the process of what trigonometry is and how we can use it. So before we get started, let's break down the word trigonometry. So trigonometry, tri is 3. Gon is sides, metry is measure. So we're actually finding measurements of three-sided shapes, which are triangles, and we are going to be focusing on right triangles. So most trig only applies to right triangles, so that's where we're going to be focusing. So it's going to help us find side lengths and angle measurements of right triangles. Before we jump into totally new stuff, I want to kind of connect it to stuff that we already know and have connections with. So we are looking at right now some 30, 60, 90 triangles. So if you remember, all 30, 60, 90 triangles are similar, and you might recognize these patterns of sides. So we've got our short leg, our long leg, which is short leg root 3, and then our hypotenuse, which is short leg times 2. Okay, we're going to look at a couple ratios here. So trigonometry involves ratios. So a ratio is just a comparison of two or more things. So we're just going to be comparing two sides. So for my first picture here, I'm going to compare this side right here, the 1, which is, I'm going to call it across from my 30-degree angle, and I'm going to compare this 1 root 3 to it, which is, I'm going to say next to my 30-degree angle. So if I write that as a ratio, that would be 1 over root 3. Now, if I type that into my calculator, we're going to get approximately 0.577. So the ratio of this side, which is across from 30, and the side that's next to the 30 is 0.577. Now, in my second 30, 60, 90 triangle, I'm actually going to compare the exact same two sides. So the side that's across from my 30 and the side that's next to my 30 to root 3. And that's actually going to reduce down to the exact same thing. 2 divided by 2 is 1. So that's also going to be 0.577. And then for our third triangle, we're going to compare the same two sides again. So we're going to have 4 over 4 root 3, which again is 1 over root 3, which is approximately 0.577. So no matter what size my triangle is, the ratio of the same two sides of every one of these triangles gives us the exact same constant. So we could do the same comparison with a couple different sides as well. We could do the comparison of the side across from the 30 and the hypotenuse, 1 over 2. That would actually be the same as if we did the ratio of across from our 30 and the hypotenuse, 2 over 4 equals 1/2. And the same thing here, if we did 4 over 8, it would also equal 1/2. So as long as we're comparing the same two sides in every triangle, we're going to get the same constant every time. All right, so let's give ourselves a little bit of vocab as we talk about this. So the first thing, our first vocab word is reference angle. You may have noticed when I was talking about the ratios that I described where the side was based on one angle. So I said across from the 30 and next to the 30. 30 is our reference angle. Across from the 30, next to the 30. 30 is our reference angle. So our reference angle is the angle from which we're looking, or the angle we're comparing the sides to. The angle from which we are looking. Or we can say comparing the sides to. Now, when you know the angle measurement, you'll just put the angle measurement in there, or if it's given to you, the angle will already be in there. But if you don't know it, you can actually use a Greek letter. So this circle with the line through it is actually the Greek letter theta. So you'll see that a lot. The other one that you might see quite frequently is kind of like this fish-looking one. This is alpha. So when you know your angle measurement, it'll be in the picture for you, but if you don't know what it is, usually one of these two will represent the variable. So we use Greek letters when we're looking for angle measurements, and we use like X and Y if we were looking for a side length. Okay, so now we know what angle we're looking from, our reference angle. Now, once we know that reference angle, the opposite side is the side across from that reference angle. So when I talked about 1, this would be the opposite side because it's across from 30. So it's the side across from the reference angle. The adjacent side is the side that's next to my reference angle. So let me actually label this. So this guy would be my opposite side because it's across from the 30. This one would be my adjacent side because it's next to the 30. So you might remember we've had the word adjacent before, so angles are usually adjacent if they're next to each other. So same thing here, it's the side that is next to your reference angle. And the hypotenuse is just the normal hypotenuse. Your hypotenuse is the side always across from the right angle, or the longest side. Now, in the triangles that I was talking about up here, I used 30 as my reference angle. So when 30 is my reference angle, the 1 is opposite and the 1√3 is adjacent. Over here, if 30 is my reference angle, 2 is opposite and 2√3 is adjacent. And if 30 is my reference angle, then 4 is my opposite and 4√3 is the adjacent. But if I wanted to look from 60, if I was looking from 60, this is 4√3, 8, and 4. If I was standing right here, that's me. Here's my ponytail. If I was standing right here, then across from me would be my opposite side, and next to me would be my adjacent side. So you can see that when my reference angle changes, my sides change. So instead of the opposite being the vertical, now the opposite is the horizontal. So your reference angle makes a really big difference. Okay, so now we're going to look at a triangle that I know is a right triangle because I'm telling you it's a right triangle, but I don't know an angle measurement, so you can see that I have a theta in this spot right here. So since this is my given angle right here, theta, that means I'm going to be standing right there at that angle. So the opposite side from theta would be this guy over here. I'm going to call it A. My adjacent side, I'm going to call it B, and my hypotenuse, I'm going to call it C. Now, we can compare any of these sets of sides. So in the top up here, we were comparing the 1 and the 1√3 side. So we've already compared A and B, and we noticed that no matter what, that gave us the same constant. I'm going to call that constant number 1. Now, we can compare other sides as well. So if I compare A and C, that's going to give me, as long as my triangles are similar, it's going to give me a different constant. So like, I think we talked about that one already. So if we did 1/2, that is 0.5 if you turn it to a decimal, 1/2. 2/4 would be the same two sides, is 1/2. And 4/8 gives us the exact same constant, 1/2. I can compare B over C as well, and that's going to give me a totally different constant. Call that constant number 3. So if we look at these triangles up here, B and C would have been the adjacent side and the hypotenuse if we were using this as my theta. So 1√3/2. This would have been 2√3/4. So 1√3/2, 2√3/4. Do you see that these would reduce down to the same thing? And then if we did the same two sides over here, 4√3/8. These will always reduce to the same thing. Now these constants have a name, and so next we're going to talk about what their names are. So when I compare A and B, in this case A is my opposite side and B is my adjacent side, instead of calling it constant 1, someone somewhere made up the name tangent. So anytime we are comparing the opposite side and the adjacent side, we're going to call that the tangent. Anytime we compare, if we look at A and C, so A is still our opposite side because we're still going to be talking about theta as our reference angle. C is our hypotenuse. So anytime we do A over C, so opposite over hypotenuse, we're going to call that sine. And then B over C, which is going to be our hypotenuse and our adjacent side, so adjacent over hypotenuse, we're going to be calling that cosine. So now we're going to look at a little table to help us organize this information. Okay, so I've got a table here. We're going to fill this table out. You can see that I don't just have those 3 trig functions. There's my tangent, my sine, and my cosine, but I have 3 other ones as well. So there are 6 trig functions total. And the reason there is 6 is because if we look back here at these, I compared a over b and called that tangent. But I could also compare b over a. So I could do its reciprocal. So if I compare b over a, I'm going to get another constant, but that constant will be directly related to this one. It's its reciprocal. And so it has a name as well. Same thing with a over c. I could use the reciprocal and do c over a and get a new constant, and I could do c over b and get a new constant. So that's why there are 6 functions. 3 of them are traditional regular functions, and then these 3 down here are called our reciprocal functions. All right, so let's start with our sine function. So do you remember which one was sine? In the sine function, from our given angle theta, we were always going to compare opposite and hypotenuse. So first of all, mathematicians, as you know, love abbreviations. Sine is abbreviated SIN. Now it's going to be really tricky to try to train your brain that whenever you see SIN in math class to say the word sine instead of sin. So we're going to have to practice that as we go forward. So the definition of sine is opposite over hypotenuse. So no matter where your given angle is, no matter where theta is, as long as you're looking at your opposite over your hypotenuse, then that is going to represent the sine of your angle. Now, whenever you write a trig function, you always have to tell people what trig function you're talking about and then what your reference angle was. So our reference angle here was theta, so sine of theta equals opposite over hypotenuse. All right, our next our next trig function is cosine, and it's abbreviated COS. So cosine of theta, if theta is still our reference angle, let's go ahead and draw a picture. Now I'm going to draw a picture that looks different than that one this time, just so we can kind of start getting our heads wrapped around the sides that we're going to need. So cosine, if you remember from over here, cosine in our picture was b over c, and we have that labeled as adjacent over hypotenuse. So our cosine is going to be the adjacent side over the hypotenuse. So if we're looking in this picture right here, hopefully the hypotenuse is really easy to identify. It's the one that's across from the 90, and then the adjacent side is the side that's next to it. So in this case, that will be the vertical side right here. So that would be adjacent over hypotenuse. So no matter where your angle measurement is, it's adjacent over hypotenuse. All right, tangent is abbreviated TAN. So tangent of theta. And if we go back to this guy over here, if we remember, we used A and B, so that was opposite and adjacent. So tangent's definition is opposite side over the adjacent side. All right, so let's draw a triangle that's a little bit different. Now your theta will never be the 90-degree angle because we already know that angle measurement, it's already 90, and so your theta will always be one of these two acute angles here. All right, so if theta is right here, then the opposite side is going to be the one that's across from it, and the adjacent side is the one that's next to it. It's the one that makes up the angle that's not the hypotenuse. All right, now let's attack these reciprocal functions. So reciprocal, remember, means just to flip that fraction upside down. So when we talk about the cosecant, first of all, its abbreviation is CSC. So we would say the cosecant of theta. Now, cosecant is the reciprocal of sine. So we are going to flip the sine ratio over. So cosecant is hypotenuse over opposite. So its picture will look exactly the same as sine because it's the exact same two sides. I can draw my picture differently though if you want, so I'll put theta in a different spot this time. So opposite and hypotenuse would still be these two sides here. So I would be using those two sides. Now secant is the reciprocal of cosine. So secant is abbreviated SEC. So the secant of theta is going to be hypotenuse. We're going to flip this guy over. Hypotenuse over adjacent. And its picture would look the same as cosine. Now, to remember which one of these goes with which, it's not very, I don't know, like straightforward. Like in my mind, cosine and cosecant both start with co, so they should go together, but they don't. It's sine and cosecant and cosine and secant. So I always remember S and C are always going to go together, sine, cosecant. S and C are always going to go together, secant, cosine. Now the last one is a little more straightforward. It is cotangent, so it's going to be the reciprocal of tangent. So cotangent is abbreviated COT. So it is going to flip over tangent, so it'll be adjacent over opposite. And its picture would be the same as the tangent picture because we're using the exact same two sides. Now, this can be really overwhelming. There's a lot of information here. So how are we going to remember what goes with what? So someone a long time ago came up with this nice little abbreviation. It's SOHCAHTOA. So is actually stands for sine, is opposite, and hypotenuse. So SOH, sine is opposite and hypotenuse. So cosine, CAH, cosine would be adjacent over hypotenuse, CAH, and then TOA is tangent, and that's equal to opposite over adjacent, TOA. Now, cosecant, secant, and cotangent, we don't have a nice little phrase for that, but if you can remember this one, then we're just going to go in reverse. So cosecant would be hypotenuse over opposite, secant would be hypotenuse over adjacent, and cotangent would be adjacent over opposite. All right, we're going to finish out with just two quick examples. So here's our first one. Find the sine of theta. So first of all, we need to remember sine is what ratio? We don't even need to go all the way up there. We can just use our SOHCAHTOA. So sine is opposite over hypotenuse. So if theta is right here, let's start out by labeling our sides. So 4 would be across from theta, which would make it the opposite side. 2 is next to theta, but not the hypotenuse, so it's the adjacent side. So here's our hypotenuse. So then how do we find sine if we need opposite and hypotenuse if we don't know the hypotenuse? Well, we could call it x, or y, or z, or a, or h, or whatever, but if we know two sides of a right triangle, we can always find the third side using the Pythagorean theorem. So we're going to do that to find the third side. So 2 squared plus 4 squared equals, we can call it c squared, x squared, whatever you want to call it. So we're going to have 4 plus 16, so that's going to be 20. So c is equal to the square root of 20, which you may remember how to break that down. That's going to be 4 times 5, so it'll be 2 root 5. All right, so that means the sine, what trig function are we doing? Theta, what was our reference angle? Opposite over hypotenuse would be 4 over 2 root 5, which can reduce to 2 over root 5. Or we can remember how to rationalize our denominator. Do you remember that part? Root 5 over root 5. So then we could also write 2 root 5 over 5. All right, last one. What is the tangent of 60? Now we don't have a picture of this yet, but we do know we're talking about right triangle trig. So we're going to have a right triangle. One of our angles is 60. We want to know the tangent of 60, which means we know our reference angle is 60. So we can go ahead and label our sides. Opposite, adjacent, hypotenuse. Now we don't have any side lengths, but we do know that this is a 30, 60, 90 triangle. So we can pick a short leg side and then just use our sides, the short leg root 3, and short leg times 2 to just find the other side. So pick a number that you want for your short leg. I'm going to pick 7, everyone's favorite number. So if my short leg across from my 30 is 7, then my long leg would be 7 root 3, and my hypotenuse would be 14. So we want tangent. So tangent is TOA, so opposite and adjacent. So I need the opposite side and the adjacent side. So tangent of 60 for this case would be 7 root 3 over 7, but that's going to reduce all the way down. 7 divided by 7 is 1 to the square root of 3. All right, if you have any questions, please reach out to Miss Regal or myself. We'd be happy to answer them for you. Otherwise, have a fantastic day.